Yeah, you're in the lab with your mate JJ. Today is Module Monday. My silly job title for today is Conductor Captain. Today I'm the Conductor Captain. And this is the inaugural Module Monday. I was threatening for some time to do Maths Monday, where I was going to go back and do high school mathematics on Mondays, but I decided that perhaps most people wouldn't want to go back to junior high school and do basic algebra. They're quite possibly beyond that at this point in their life. So I thought rather than do something that would be perhaps unpopular and boring, that I might do something else instead. And thus we have Module Monday. Up in the corner here, the left-hand side of component drawers up there, they're the various sensor modules that I have at the moment. Not all of them, but most of them. I also over here have actuators. And so these are mostly sensors, which are usually mostly just inputs. And then over here I've got a few actuators, which obviously outputs. So modules includes sensors and actuators. So I think either of those types of components are fair game. I did think about, looking at very basic things like resistors and capacitors and inductors and transistors and other things that you might not usually call a module, but that you'd perhaps call a component. And maybe I'll do that at some point and just look at the basic passive components and some of the active components. We'll see, but there's no hurry, and there's heaps of modules to do. There's probably about 30 of them up there, perhaps not that many, but in that order, and there's others floating around the place. So I think we'll have plenty of fodder for this particular feature of the show. And I thought today I might start with something simple. It was in fact just the drawer up at the top left, so it was kind of the logical place to start, and it seems to be a pretty reasonable place to start too, because this module is the photo interrupter, which is actually a very simple circuit. It's just an LED and a photo resistor or photo transistor or something. In a little holder that will detect if a slot has come in or out. So it's you need to interface to it mechanically, but it can detect, I guess, if something's closed or if it's come open and this sort of thing. What I will do, what will I do? I guess I'll show you the device on the bench just quickly. Then I'll pop over to the computer with you and we'll see what information we can find about it. I'll show you where you can buy it at AliExpress and the various bits and pieces you can search for to try and find similar modules. And then we'll pop over to the bench here, and I think we'll have a look. We'll put up a test rig and we'll have a look at the signal, I think, on the oscilloscope, or maybe just on a multimeter. But we're basically today just going to be looking at a photo interrupter, which is a module that you can get. It's designed to interface with a microcontroller like an Arduino or something like that. It's got 3 pins, and it's quite simple. So yeah, today's going to be the first Module Monday, and basically it'll just be letting you know what sort of modules are available for your Arduinos or your microcontrollers, and what you can expect from them and how they work and this sort of thing. So let's jump over to the bench. I'll show you what we got. Then we'll jump over to the computer, and then we'll jump back over to the bench to actually play with it. Here on the bench. Now, this is my photo interrupter drawer. Let me see if I can zoom in on that. Let's have a look there. So yeah, it's my photo interrupter box. I've got 1, 2, 3, 4 of them in the back here. They're all pretty similar. They're not all exactly the same. You can tell because of the silk screen. Some of them vary a bit. Some of them have the S and this negative terminal mark. Some of them don't. But they all look basically the same. They've obviously got 2 current limiting resistors in there. and they've got, I suppose, an LED and a phototransistor, I guess it is. It's not perfectly clear. In that, on the other side there is where you interface with them, and we'll need to find something to stick in there, maybe like this, and you stick that in there, and it breaks the beam, and causes the output to change. So we've got 1, 2, 3 pins. One of them will be power, one of them will be ground, and the other one will be the output signal. We'll have to guess which is which, I suppose. Um, and we'll do that together shortly. So this is it. I'll take you over the computer and I'll show you where you can get them and what they look like on the internet. All right. Well, here we are on the computer. And the screen that we're looking at here is just an image search for KY-010 photo interrupter module. I got that KY-010 from over here, which is um, the AliExpress listing I found for the module that looks about right. Have a look at these modules here. I'll just click through the various images. This is the back of the device, as you can see there. So as they say, it's the KY-010 broken light blocking photo interrupter sensor module for AVR PIC DOA starter kit KY-010. And there is some information, but it's all pretty terrible. The brand name is just like random keyboard gibberish. It says that it's a voltage regulator, but of course it's not. But that probably doesn't matter very much. And then it gives you some basic code to use the device, assuming you've got the output pen hooked up to pin 3 and you want to use pin 13 as your output. Then you can read a value into value by well, you set up the output LED and the input button pin, and then you do a digital read on the button pin, and if the value's high, then you set the LED high, otherwise you set the LED low. So it should just go on and off as the photodiode gets interrupted and not. And then it shows you again all of those photos that we've seen earlier. This is the back of it. This particular one has the S and negative terminals marked. So let's jump over to the oh, did I show you this bit? I think I did. So like, yeah, we'll jump over to the bench and we'll put this thing through some tests. All right, so we're back on the bench. We've got ourselves a little breadboard to play with. There's our module at the back there. I'll just throw you over to the power input. We've got it set at 5 volts, so that will run through these two jumpers here, which will run into our breadboard on negative and positive power rails. Now these are switched off at the moment, but we'll be able to switch them on. Now this is our multimeter, and we're going to put it in voltage mode. And we might as well just give the old, oh no, I got that wrong. I put the colors in the wrong way around. Dear me, how did I get that wrong? Anyway, let's put positive there and negative there, and if we hit the on-off button, up it goes to 5 volts, which is what we wanted to see. So we'll turn that off. Now we're going to have to do a bit of guessing about the inputs and outputs here, but let's try sending. I can't imagine we'll destroy it if we get it wrong. So let's live dangerously, shall we? Now I'm going to need some jumpers here, and I've got a box full of them. Might as well choose a red one for positive, and we've got a black one somewhere. There's what are we going to use for our signal? Orange will do, and we're still looking for a black one. So there's a black one in there. Let's take him off there. So these are female to male jumpers, which is what we need. We've got female on this end, and then uh, uh, female on this end, male on this end. That's what we want. Now we're just going to take out this, and I'm going to put the what do I need? I'm going to put the positive jumper for the multimeter on that middle probe, which I'm guessing is the output. Not 100% sure. S might be for signal, which is the output. Not sure. But if we put negative here, well, we'll just see what happens. Let's see what happens. So let's put negative on this side. I think that's pretty reasonable guess. Put that on there, and then see what happens when we put that on there, and then throw some power into this thing. All right. So okay, that didn't change much. So let's try running this power from the positive line, and let's just see what happens. So we turn him on. All right, we're getting 1.1 volts and 0, 1.1 and 0. So now what we'll do is we'll turn it on, and let's interrupt the signal. So let's put the cardboard in the middle there, and it didn't seem to affect it at all, did it? Not really at all. Okay. So what we'll try doing is just changing the pin out here. Let's put positive power to the middle, and then use the far right pin as the output. Let's see what happens if we do that. Bang. So it's 0.18, and if we interrupt it, it goes up to 4.88. So that's working properly now. Goes down to 0.084, and then when we interrupt it, so it's active high, and it's 4.897, so that's working for good 5-volt logic there. So I think that might be everything to show you about this circuit. Let's take you over to the farewell cam, and we'll wrap up. I thought before we wrap up that I might just actually interface this module with an actual microcontroller. So I've got a box of Arduinos here. This one's USB-C, USB-C. That's not C, that's B. I'm looking for C. I'm not seeing I'm not seeing a C. And if I can get an adapter. We want an adapter from C to B. We got one? There's one. Okay, cool. Well, just drop the adapter there. I've got a USB-C cable that runs in here. So if we just put that into the USB Type B adapter, then we can power our micro. So here's a micro here. Is it going to need power? Probably not. So I don't know what program's on there at the moment. Now, what I'll do is I'll just I'll get an Arduino IDE running, and we'll get some code in there, and we'll see this thing work. Give me a sec. All right, so um, this is my Arduino sketch. It's just called the KY-010 photo interrupter. The code is just the code I copied out of the AliExpress page for the device. So this is the device or the module at AliExpress, and this is the demo code that they gave us. So that's running here in here. I've just pasted it in directly. It's all a bit of a mess, so we might as well clean it up together, and we can at the same time have a look at what we're dealing with. So the first thing we do is we set the LED out. Well, I suppose the first thing we do is to define our output as LED on pin 13, and pin 13 on the Uno is the onboard LED. And then we use the button pin at 3, and that's the input device that we're going to be using with our KY-010 photo interrupter module attached. So, and then we've got a value here, which we use to read the value of the pin. So the first thing we do is we set the LED as the output and the button pin as an input. Then we begin our loop. So the first thing we do in our loop is we read the button pin. And we get a value for that. And then if the value equals high, then we write the LED as high, so that will turn the LED on. Otherwise, we write the LED as low, which will turn the LED off, and that's everything. I guess we might as well just pop that out. So there we have it, LED 13, pin 3, and so on. So let's just together, we'll just jump over to the we jump over to the bench. Where are we? Bench is here. All right. So this is the Uno. You can see the USB-C is running into the USB Type B adapter. I've got the module wired in. We've got plus 5 volts into the module. We've got ground into the module, and our orange pin, which is our module output, is added to pin 3 on the Uno. So let's just duck back over to the IDE, and I'll show you. This is well, I suppose I should show you. This is the Arduino Uno on COM6, and we're just going to upload. So that will compile our sketch and upload it to the Arduino. So it's done uploading. It's got the latest version on here. So let's switch you back over to. Oh, did I just? Oh dear me. What am I going to do? I'll pop you back over uh, to here, and I'll just show you what I tried to show you just then. I think I made a mistake. So yeah, I tried to show you that the board is the Arduino Uno, and it's on COM6, and we just go sketch upload, and it uploads the sketch, and then once that's done, I'll throw you back over to the bench, and here is the thing. So we've got our latest program on here. We've got our module all wired in. So what we're going to do is we're going to break we're going to interrupt the photo interrupter by sticking a wedge in here. What we'll expect to see is the onboard LED on the Uno go on. So there it goes. So we take it away, it goes off. Stick it in, it goes on. Can you see that? Yes, you can. So I suppose I can show that to you a bit better if we zoom right in on everything. So just using the bookmark here to break the circuit. So that's how the photo interrupter module works. all programmed into our Arduino and everything. And of course, this is the inaugural Module Monday, but we might make the rule that in order to qualify as a module, it has to be something we can interface with an Arduino Uno. And we'll keep this Arduino Uno handy, and we can use it week on week to test out our new models. So today was the KY-010 photo interrupter. So with that, I'll throw you over to the farewell cam, and we'll wrap up. And that's a wrap. So I think we figured that out pretty well. We had a false start there. I got the pins the wrong way around, but there was only two ways it could really go. And the second one was the one that worked. I will put some schematic details in the show notes. Also, if you search for KY-010, you'll find schematics and such available. I guess we could have had a look at those first, although it didn't really matter, did it? We figured it out. We saw about 0.2 volts on the low and about 4.8 volts on the high, which would be plenty good enough for a microcontroller to read. So yes, today the inaugural Module Monday. We'll see how we go and if we're going to keep doing it. And yeah, that concludes this video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.